Well, hello everyone. So Dan's already said a bit about who I am. I would also like to point out that I submitted this talk before I knew that the keynote would be all about serverless functions, and you'd have someone who has been working with them rather a lot longer than I have telling you all about them. So hopefully I'm not going to fall foul of too many of the things that we heard about in that keynote. So serverless computing, a quick primer, maybe for those of you who didn't make it to the keynote or were, just overwhelmed by the amount of information that was there. Serverless computing is about putting stuff in the cloud. That's really what it is. You write and deploy application code, and then the cloud provider is responsible for all of the scaling and wiring together and maintaining of that infrastructure. So you don't have to go through and maintain your own virtual machine images or whatever as the base of your operating system platform. You just provide some application code. So it's sort of like a halfway house between platform as a service and software as a service, in that you get to write the software, but you don't have to maintain the platform. And there are different providers that have different API requirements for what it is that you do. Now, normally your application that you write is a stateless thing, and this is what starts to be known as function as a service. So you have something that is a stateless function that can be deployed pretty much anywhere, on demand, spun up, fired. Just because it's stateless doesn't mean that there is no state at all. You're able to use things like data stores from your cloud provider, or access large data somewhere else, but you don't have any local storage of state. Sometimes you do get temporary state that you can use for maybe holding some cache of data or holding on to a database connection that you had before. And the reason for that is that if you get repeated calls to your function and you have to set up everything from scratch every time, that performance sucks. So the main thing is that this is temporary cache. It can be thrown away by the provider for whatever reason they feel like. And I mean, like, seriously, just between direct invocations that happen microseconds apart, the cache may suddenly be gone and you can't complain. And the other important thing is that you really are just writing a function. The actual way that invocations happen and data gets in is separate from what you've written. So you're defining something like a trigger. So a trigger will map you to an HTTP request, perhaps, or you can monitor, say, an S3 bucket if you're using Amazon, or get an MQTT message coming in from somewhere. And those are the things that are going to cause your function to run. And that is separate from the thing that you write as the function. So why is this good for IoT? Well, firstly, it's easy to deploy stuff, and it's easy to keep the platform up to date because that's somebody else's job. With IoT, you're going to have huge numbers of these things, so making it easy to push them out is a good thing. Not having to maintain your own scripts, not having to do all of the DevOps work that we were hearing for ages was such a great thing. It turns out to be a real pain in the neck if you're having to do it for things that are scaling to tens of thousands of deployments. Also, IoT scales like nothing else you've ever seen, right? You start with your basic, like, oh, I'll test this out, and oh, I'm collecting data from my one sensor that I've got sitting on my desk somewhere, and my laptop's processing it, and I'm doing this output, and aren't I great? And then you try and take it to the real world, and someone says, okay, I want to put this in my factory, and I'm going to need a sensor every 5 meters. And then my factory, oh yeah, the total footprint is like 6 hectares. That'll be fine, right? And suddenly you've got, oh, what do I do with 100,000 sensor readings happening every 10 seconds? Yeah, it gets pretty hard. So IoT is going to be the kind of thing where you see bursts of events that would overwhelm any normal system, and that you've got potentially hundreds of different IoT devices that you all want to trigger the same function. And if you have to write a different adapter mapper for every single one of those, then your life will be hell. And finally, as was mentioned in the keynote, the reason that people like this is that it's cheaper, right? Or at least it should be. If you've got pay per invocation, and you're only paying for the memory and CPU that you actually use, then theoretically it's cheaper than having lots of VMs. Now, your mileage may vary, as always, and if you get sudden unexpected spikes in events, then your bill could suddenly go up a lot more than you expected in a way that it simply can't if you've got a fixed number of virtual machines. You know how much that will cost you, but it should be cheaper. So let's talk Java functions as a service. And I'm going with Amazon Lambda mostly because it wasn't the first one, but it was the first one that was successful. So a lot of people have played with it. They may be familiar with what I'm about to talk about. And if you're using Java at least, your application is a jar file. Your entry point is a method in a class in that jar file. It can implement one of the AWS interfaces, but it actually doesn't have to. Your method just has to have a suitable signature, and you can point at it, and they'll use reflection to call it. And your dependencies get packaged into that one jar file that you deploy. So this is what would typically be known as a fat jar, and they actually recommend that you use the Maven Shade plugin to shade the dependencies in there so that there's no way that you can clash with whatever else they've got in their runtime. The entry point, so that's the name of your function, so the class and method name, and the trigger that's going to cause that to be called are defined in a separate descriptor file. So those don't belong with the core function, they belong outside. And different providers do this in a different way, but broadly it's all pretty much the same, whether you want to use Azure, Google, who obviously don't support Java in their cloud, but they have a variety of other things that do it pretty much the same way. OpenWhisk, again, as we saw, it works kind of like this. But does this sound familiar to anything we know? We have some kind of nominated entry point, metadata which describes the function, and then some kind of managed dependencies to try and protect us from clashing with the platform and make sure that what we deploy is deployable. These are OSGi services. That's what function as a service is, just an OSGi service that provides you with a function. If you have the whiteboard pattern in OSGi, the things that you are providing to the whiteboard are serverless functions. You're saying, I have my JAX-RS endpoint, I have my servlet, and I want it to be hosted somewhere. And I don't really know or understand or care about the web server. That's not my job. That's someone else's job. So OSGi has been serverless for a long time. Well, so in the case of a Lambda, can a function have side effects? Then you can't really store state between function calls, so you can't have a side effect like that. And you get copies of the parameters as they come in, right? If it's an HTTP request or an MQTT message, you can't really cause the person who sent it to learn something more. You could, as a result of your function running, call another function, and we'll get onto that, but the answer is not really. But you can see here from this picture, I have some user who makes an HTTP request. It's going into the JAX-RS whiteboard runtime, which is the bit that I didn't write, I don't really care about. And then I have my function bundle that's provided this service, and I have my dependencies. And this is exactly what's happening in any function as a service environment. So we have our application is a bundle rather than a jar file, but then a bundle is a jar file, so it's not really any different. Our entry point is a service that we describe. Actually, we do better than Amazon do with their Lambda, because describing the entry point in the function means that when you're deploying it, what you do is you describe the trigger, but you don't need to then tell them what to trigger, because that's already there baked into the function. So the person deploying it needs less information about what they're deploying. For HTTP input, this is what we have in OSGi right now. So the question is, are we already done? Is this a very short presentation? Well, the answer is obviously no, because I said one of the things about your IoT triggers is that you don't want to have to write separate adapters for every protocol. That will really hurt. So what we've got is an example for HTTP using REST, but what if we had some other means of triggering? What if we wanted to do something else? Because IoT data comes from all over the place. People use HTTP a lot because it's the thing that everything speaks. But fundamentally, HTTP does not work for most devices. HTTP is not good for low power. HTTP is not good for I don't have any kind of TCP. So what OSGi does is it actually makes it really easy to plug in connectors, but we want some kind of generic connector and then a way of writing our function so that we don't have to deal with the specifics of the protocol that's coming in. You shouldn't care in your function about how the data that you're processing got to you. The data, however, should be typed. You should have a defined schema which says this is the data that I expect and the format I expect it to come in. Because if you don't have that, it becomes really difficult for people to work out what they should provide you and how they should call you. Also, you shouldn't directly call another function. You should do something which is going to trigger another function through the standard mechanism that functions are triggered. And this is because otherwise, if you try to directly call something, you're getting around the how do I deal with the function's already running somewhere else that wasn't what I expected, or there's a warm function there that's ready for me to call, but the place that I'm going to go to is cold and the latency will be bad. You need to go through the correct entry point for functions as a service, which is through the event that's supposed to trigger that function. So how do we use functions in OSGi? Well, as Dan mentioned, this has come about mostly through my involvement in the BRAIN-IoT project, which is funded by the European Union through Horizon 2020. And we have an example here of one of the core use cases for BRAIN-IoT. So we have here a water utility. This is actually a real water utility in A Coruña in Spain. So that's northwestern Spain. And they have all manner of sensors for the kind of weather and the state of the river, from which they take water, process the water, and turn it into the drinking water that is given to the city. And obviously they don't want to waste the water. It's bad for the environment if they take too much water from the river. It's expensive if they have to purify too much water with chemicals and then throw it away because it's been sitting around for too long. And they also get into trouble with people if there are water shortages because they haven't done enough to meet spikes in demand. So they have quite a difficult balancing act here, and what they really want is for IoT to help them manage that better, because that way they can save on input costs with chemicals and on energy, and just generally have a more environmentally friendly and cheaper to run system. Also, unsurprisingly, security is an issue, because it turns out what you don't want people to be able to do is accidentally add 10 times more chlorine to the water. That's not so good for the people who are drinking it. Now, BRAIN-IoT is built from things that are interacting, and we call them smart behaviors. So it consumes a data event and sends potentially a data event. An event can be something that's triggered by a sensor or a user somewhere, or just a smart behavior. So one of the things your smart behavior does is it might have the equivalent of a cron tab, and it just every hour it sends an event to say, hi, I'm here and I think the state of the world is X. And that's still a perfectly valid thing for it to do. But these events come in, get processed, turned into more events, collapsed into fewer events, and eventually something happens. And you can implement this however you like. Each smart behavior is totally decoupled from all the others. And they have this typed data. It makes it a lot simpler to develop if you've got type-safe access to the data that you get. And your unhandled events are processed by special behaviors, which are used to trigger dynamic deployment of new smart behaviors. So in OSGi, we have event admin. It's been around for a while, and it delivers data to an event handler. You have whiteboard functions with a defined entry point. And this is a good thing. This is sounding like something we might want to use. It's also easy to take input from lots of sources. I don't know if you've actually read through the detail of the OSGi specs. I have pretty much all of them. Took a while, but there are an awful lot of mappings to event admin. For pretty much any spec that has an eventing mechanism has a mapping to event admin to say, and this is how event admin structures that event. So event admin is good for protocol independence. You listen on event admin, and you've got basically everything you need. You can also, in your event handlers, send more events. You can trigger other event handlers from your event handler in a decoupled way. Again, this is sounding really like what we would want to base not only serverless, but specifically the BRAIN-IoT runtime on. But we came up across our first problem, which is a mature specification like event admin also feels kind of old. I don't know if you've noticed, but in the OSGi specifications for the last 5 years or so, we've been trying to get rid of programming by string. So maps with string keys and object values, we do not like them. They are not fun. They are not safe to use. If you have a map with string keys and object values, you have to know what keys you're expecting. You have to check that the keys are there. You then have to get the value out as an object, check if it's the right type, convert it into the right type. It's a mess and it's a pain. What we want is something that is type safe, so I can access a field that the compiler will tell me if I screw up, and that field will have a type that I don't need to worry about the object not being that type. So we need the good things from event admin. BRAIN-IoT needs something that does that. But we also need some things that are missing. So we need events that are strongly typed. It is 2019. I am done with maps. We also want to be able to monitor the event delivery. Because at the moment in event admin, the only way that you can monitor the events that are going through is to register an event handler that listens to all the events. Now, I don't know if you're aware that in quantum mechanics they say, yeah, you can't observe a system without changing it. It turns out event admin is quantum mechanics. You can't observe event admin without changing what happens because you've added your own event handler. And particularly when you want notification of events that nobody's handled, if your monitoring thing is handling everything, then suddenly your system has changed quite a lot. So event admin is not fit for purpose for BRAIN-IoT. So we want to update it. We want to make it better. We want Typesafe Objects. And OSGi has things called DTOs, which are designed to be type-safe objects for transferring data. And I like them. I know some people like them slightly less because they don't like having public fields that anyone can change. But fundamentally, they are the closest thing you're going to get to having a struct, which is really what we want, something which is a typed data structure. We want to keep the concept of having topics, but we want to not always have to care about having to create a topic. In event admin, the old style event admin, the topic is really the thing that defines the schema of your event. It's the thing that tells you what you should expect to find in the map. We now have a type-safe thing that tells you what you're expecting to find, so if you don't have a specific topic, we should be able to default the topic based on the schema of the thing that we have. So based on the type name, for example, of this DTO, we can auto-generate you a topic repeatably that other people can listen to just by saying, I'm interested in events that have this schema. Also, adding support for something that we're going to call a handler of last resort. So this is a guy who can process the untyped data. Yeah, sometimes you do have to fall back to a map. If it's a schema that you don't know before, you can't compile against it. Okay, we'll use a map. But this is the guy who's going to get called to say, nobody else listened for this. We had this event come in. They probably wouldn't have sent it if it weren't important. So somebody should do something about this. So you can see here someone who's sending to topic A, and they're listening, and that's great. But you send to topic B, and there was no one listening, so our last resort event handler is going to get that information and be able to hopefully do something with it, even if it's just log an alert to an operator somewhere and say, help. It's still better than the event disappearing into the ether. We also want to be able to allow, at least in a limited sense, schema conversion. So if someone sends a data event of type foo, and what they really want to do is consume just a bit of it in, say, some type foo bar, they should be able to consume as a foo bar, and the eventing runtime should be able to do that conversion for you. So you give yourself a view of the data that was sent, but maybe it's just a small subset of the data that you're actually interested in. As I say, we also want this event monitor API. Rather than having some disturbance in the system by adding an event handler, we want something that's actually going to be able to just get a stream from the event bus itself, providing us with access to information about the events that are being sent. And we want to push this back to the Alliance because we are good citizens. So you can see the RFC for this work in GitHub in the public OSGi design repo right now. Note that the proposed changes would break compatibility with event admin, mostly because the event handler interface is only going to ever accept an event, and it's a consumer type, so either we're creating a whole parallel set of packages or parallel set of types, or we're breaking to go to version 2. And if we're going for parallel set of types anyway, why would we not consider doing it as a new spec? We're open to people telling us no, they really want it to be event admin 1.1, but it's going to look funky. So, putting all of this together. I'm going to sit down for this. So hopefully at the back you can see we have the BRAIN-IoT dashboard here. And this gives us access to a number of things. So we have the smart behaviors here. So these are effectively the serverless functions that exist. And we've got here the example ones that I cooked up for demonstration to the EU some months ago, which is a virtual security light. So we have a sensor, which is it's a button on a web page, but it's mimicking the same effect of having an infrared sensor that is just going to detect when something has broken the infrared beam. We have a light bulb that is, again, a picture on a web page, but it has variable brightness, and so you can turn it up and down. And we have this security light behavior. So this is something that is going to attempt to interpret the input from the sensor and try to do something with the light bulb in order to warn people that something has happened. And you can also see we have here a nice event monitor view, although it turns out we don't have any events at the minute, which is fine, we don't expect to. So if I go back to the behaviors, I can actually install, in this case, the sensor onto the one node. I thought about trying to run this in the cloud over the Wi-Fi, and it turns out the Wi-Fi's been pretty good this year. I don't know if you've noticed, but historically that has not been the case. So, and if we go and look now, you can see we've had, we actually use the event bus. We eat our own dog food internally to do things like installation. So you can see we have an install request where it asks to install the sensor, and then we have a response which told us the install went okay, which is a good sign. So if I now just refresh this page, yeah, this guy is alive and here. And if I just get rid of that for the moment. So if I trigger this sensor, it's going to cause a whole bunch of stuff to happen. And what I'm going to focus on initially is attempting to reload the light bulb page, which is currently not there. And suddenly it is. And you'll see that we've got events slowly counting down and the bulb's getting dimmer until it's off. So what actually happened there? Well, if I increase the number of rows per page, sorry, I'm zoomed in so that you guys can see at the back. I get it makes a slightly funky UI experience. But you can see, so that's the management response that we had previously saying that everything installed okay. We then have this sensor reading that's appeared. So that's from me clicking the button on that page. And the first thing that we see after that is this management bid request. And what this is saying, if we take a look at it, is, I got a request which ended up at the last resort handler, and it was called this. Please help. I think that something called this behavior impl will be able to deal with it. Based on having looked through the marketplace of behaviors that I showed initially, it was able to say, there is a person here who can process this kind of event. And there's only one of them, so I reckon trying to install that is a pretty good bet. So if we go back, we'll see that after the bid request, there was a response. Now that response is actually from a node that's looked and said, yeah, I could install that if you want. So we then get a request saying, okay, yeah, please do that. You over there install this thing. Like, okay, installation's done. And then you'll see we got another sensor reading DTO. And I only clicked that button once. And what's happening here is that the last resort handler is then able to replay the event data that it had from before and say, okay, somebody's listening now. Here's the event that you were interested in. And we'll see, rather than maybe what you'd expect, so these have come in slightly out of order due to the fun of multi-threading. But after this, there was a light command which resulted actually in another bid request. And that's because we've installed the behavior which has said, oh, somebody has tripped the sensor. I need to tell the light to do something. But at this point, we don't actually have a light installed. So instead, what's happening is we go through another bid request response, and you see there are a series of light commands happening because they're periodic every second. And we're going through this installation, and then we get the response. And then there's a whole bunch of light commands. And some of those are the replayed events from earlier. And then you saw we ended up joining the stream, and we had the countdown, and we saw approximately the last 6 seconds of the countdown after I'd refreshed the page. But in this process, we've managed to not lose any events, and we've managed to dynamically install all of our behaviors. So you look now, you can see everything's installed, even though I only manually installed the one thing. And this is the kind of thing that we can do with serverless functions and combining it with the sort of dynamic assembly that you get in OSGi. So as for my presentation, I think I'm coming up on the end, which is good because I'm also pretty much out of slides at this point. So I think it's probably time for me to open up for questions, and also just to remind you that please, I know I've seen a number of sessions where people haven't had this slide, but please evaluate the talks here at the community event. It's important to us. We love knowing how much you love us, so please do let us know. Okay, I think you were first. So the API is available in the design doc, so as Java doc anyway. So that's probably the best place to look, and that will stay up to date. Yep. So the events in BRAIN-IoT all have timestamps. So you know whether an event is newer or older. which is how Brain. So the last resort installation I'm showing you, that's BRAIN-IoT. That's using the features of the Typesafe eventing. But in terms of what we're doing, we have knowledge of the order in which things were created by timestamp, and we also have the ability to verify an event. There's a security token inside the event that is effectively like a message digest, so you can use that to verify that the thing has been digested and signed and not changed since it was initially created. So it's also safe to replay events doing that because you know they haven't been modified. So that's how we deal with that. Christian? In terms of storage, the events are not as big as you might think typically. So in memory is actually not that huge a problem. Also, the events that you get are only for your local framework. So in a distributed system, you have last resort handlers on every framework, and they're saying, help someone install something. So the likelihood is that you're not going to get 100 million events on a single node from a single sensor, unless that sensor is massively causing a problem, at which point you probably do want to take down that node so it doesn't flood the whole system and upset everyone. But there are options for how you choose to implement it. The current implementation is just storing them in memory because we've not found a need for anything better. But the whole point is that you can upgrade the management service system and you could overflow to disk or wherever else you want. So you have filtering just like you do with Event Admin, and if you want to target specific nodes, then you can target specific nodes by having a node target. So that's actually how the install works. So when you send out a bid, that goes out to every node in the system, or at least every node within your local view of the system. And then you wait for responses for a certain time, and once you feel you've given it long enough, you pick the best response, and then you send a targeted install request and say, you over there do the installation, rather than a broadcast everybody install. Well, it's a multi-step process in that you want to try to install somewhere where it can be installed. So an example would be in the water management use case, we actually have machine learning behavior. That machine learning behavior can't run on some of the nodes because they have different CPU architectures, and the native code needed to run it won't run. So if you're going to run the machine learning, particularly if you want the GPU accelerated version, you need to make sure you're running on a machine with a GPU. OSGi requirements and capabilities are pretty good at allowing you to determine where things can deploy. So you put out the bid, a whole bunch of people will come back and say, yeah, sorry, no, or potentially just not respond at all, saying, no, not me. And you wait, and when you finally have someone who says, yeah, I have a GPU, then you can tell them to run it. I think there was a question at the front. Um, it's self-contained, as most OSGi APIs are. It doesn't, as far as I can remember, I don't think it has any reference to the core framework API either. Oh no, so it does reference push streams, but push streams again are not, they don't require the core. No, so the monitor API gives you a push stream. So in between the nodes, we have a mechanism based on top of remote services to allow sharing between event buses globally. So the type-safe eventing as the RFC is really looking at it from an in-VM kind of model. But it's pretty easy to write yourself handlers that you can use to process events remotely. Or in your implementation, you could so you could direct stuff also to MQTT or Kafka or whatever you want, really. It's just how you want to send and receive messages or events. Now, I think I'm probably right. Yeah, I think it's probably time to wrap up. So thank you, everyone. It's been a pleasure talking to you.